All right. So in a permutation, order matters. In a combination, order doesn't matter. So suppose you have 6 different teams that are competing for first, second, and third place. How many different ways can first, second, and third be awarded? So in Algebra 2, I taught it to you like this, and you can still do it this way. There are 3 awards, all right? And so how many people could get the first place award? There are 6 different choices for the first place award. And that means somebody got first place, so now there's only 5 choices for the second place award. And then somebody got first, somebody got second, so there's only 4 choices for the last one. Multiply those together and you get 120. This is the same as this formula, which I am going to show you, and we should look at how to do on our calculator. So this is NPR. N is always the bigger number, so it's 6P3. So I have 6 different teams. How many ways can I give out first, second, and third? And I'm going to fill in the formula, n factorial. So it's 6 factorial divided by n minus r factorial, which leaves me with 6 times 5 times 4 times 3 times 2 times 1 divided by 6 minus 3 is 3, so 3 factorial is 3, 2, 1. And these cancel, and we get the exact same thing as what I did above, which is 120. Now, also, our calculators do this for you, all right? So you guys go to your lovely TI Inspire and a blank screen. Go to Menu. Yeah. Okay, then go to, gotta remember, probability. And then go to permutations. And you don't even have to fill in the formula. It's just that cool. It has an NPR with a parentheses. And you're going to fill in 6, 3, and it's going to give you the answer of 120. All right, a combination. So combination, you guys, order does not matter. So instead of saying I'm giving out first place, second place, and third place, I would just be like giving a medal out to the first 3 people. So it doesn't really matter if you finished first, second, or third. All those 3 got a medal, all right? So it's when order does not matter. So for example, how many different 5-card poker hands can be dealt from a standard 52-card deck? So your poker hand of 5 cards, order doesn't matter, right? You don't have to line them all up. It's just that if you have a flush, you have a flush, or whatever it is, okay? So this would be 52, choose 5. Always the bigger number is n, and then it's out of 5 that you're picking. So in the top I have n factorial, that's 52 factorial, divided by 52 minus 5 factorial. And we're dividing by another r factorial. This is going to take out all those ones where a combination of cards is the exact same thing and the order doesn't matter. All right? And you could plug this into your calculator using the combinations feature, menu, probability, combinations, 52, 5, and you get this really big number, 25, 98960. All right, 2,596,000. That's so many different combinations of cards, and only some are lucky. Yes. If it's on the no calculator, it would be small enough numbers that you could like cancel and multiply them out. Yeah. Like also, this turns into, you guys, 47 factorial, which could cancel with 47 factorial on the top, but it would still be really hard to multiply 52 times 51. Yeah. Okay. So here's another example you'll see in the book. There are 7 points on a circle. How many different triangles can be drawn using the points as vertices? So let's say we have a circle, and we have 7 points. 1, 2, 3, 4, 5, 6, 7. And I'm going to label them. And you can connect any 3 points and you can make a triangle, right? So, does 7, 3, 4, does it matter if I go 3, 4, 7, or 4, 7, 3? Know what I'm saying? No, it's all the same triangle, right? So does order matter? No. Order does not matter. Whatever you go in, that makes the same triangle right there. So we're going to use a combination. 7, choose 3. Because I have to have at least 3 points to make a triangle. So 7, choose 3. So you might see like this one without a calculator, I guess. So in the numerator would be 7 factorial. And in the denominator, we do 7 minus 3 factorial divided by 3 factorial. So remember, combinations always divide out an extra r factorial. So you could write it out. 7 times 6 times 5 times 4 times 3 times 2 times 1. And this is really 4 factorial, so 4 times 3 times 2 times 1. And another 3 factorial, 3 times 2 times 1. So I would probably cancel the 4, 3, 2, 1 with the 4, 3, 2, 1. Then I would divide, like 3 goes into this. Actually, 3 times 2 is 6, so I can cancel the 6 on top with 6 on the bottom. And look at that. It's a nice, easy 7 times 5 problem. So one like that might be on the no calculator test. Okay? Yeah. Back to our burrito problem, in case you were wondering. There are 20 different ingredients to choose from. Assuming you splurge for guacamole no matter what, how many different burritos can you make with the 5 other ingredients? Does order matter in your burrito? No, you just throw it in, all right? Just toss it in. All right, so if there's 20 ingredients, but I'm definitely getting guac, that leaves me with only 19, and I'm picking 5 of those 19. Then you'd plug it into the formula. All right, and it's a combination. You guys need to see it again. So obviously we need to be able to know or decide if it's a permutation or a combination. So in a permutation, does order matter? Yes. So for a Locker combination, does order matter? Yeah. So this is a permutation. Okay, if we're picking somebody to be the president and the vice president for the student body government or whatever we call it, does order matter? Yes. Yeah. So if you're assigning a position, it matters. So here's a good way to relate this. Let's say that I have a basketball team, and if I was just saying, well, how many ways can 5 people play? Then order doesn't matter. But if I was going to be like, one person's going to be the guard, one person's a center, I don't really know all the names for basketball, but then if I was assigning positions, order would matter, okay? And pizza toppings, does order matter? Nope, so this would be a combination. You just throw them all on. Whiteboard.